Okay, thank you, whoever that was. Okay, so where are we? Number 4. So site or plot plan is a civil plan. That's just all there is to it. 5, so I might have taken off a point if you just put, some of you just repeated this and said, well, it means that a ½ inch equals 1 foot. So that's not really an answer. The thing I was looking for was that, and then I know this is obvious, but I'm trying to get you to be able to state the obvious, was that you've got a scale on your plans, and then that's corresponding to a scale in the real world. So the left side, the ½ inch, the fraction of an inch is always your plan scale for a foot, and it designates a foot on the house, the real house. So mostly if you got any off this, and I'm not even sure I took one off, it was because I wanted you to be able to say it in full. Floor plan is always almost always a ½ inch. Now, you know, obviously I'm a teacher at Santa Barbara City College. I haven't seen all the plans in the world. God knows what's out there. But for a residential carpenter contractor in Santa Barbara, which if you taking this class are in the construction field in Santa Barbara, most of what you build will be a ½ inch to a foot. For reasons of space, for really huge places, they may use different, a gigantic, hospital, something they may use an 1/8 inch to get more on, but then you don't see it as well. So they usually have multiple pages of ½ inch. But it's a fair guess that 90% will be, and I said usually to catch myself. So someone can say, well, how do you know they're always that way? Well, I don't. Question 7. Section drawings, most of you got this, but what I wanted was that the reason you're cutting a section into a floor, across a floor plan is because you're wanting to see things that you can't see otherwise. And not only does the wall in an elevation block the whole inside, so that kind of plan won't do it, but there's different places in the house. So a section could be right up against one edge or right in the middle or a third of the way, depending on what needs to be seen. Number 8, this was that thing we talked about, and I said it was one way of looking at it, so it's not the only way. So most plans have objects, dimensions, and annotations. Remember, we talked about that, and it has all of those, so it'd be all of the above. If you put one of them, I think I gave you 1 credit. That's not something you have to worry about. It's just a kind of a convenient way of summarizing what's on plans. A section is, a section, where are the section lines on a set of plans? Not the section page, but where are the lines that tell you to go to a page to look at a section, usually? Anybody?
The floor plans?
Yeah, they're almost always on a floor plan because that'll give you a section across the whole width or breadth of a house. And since a floor plan is a ½ inch, usually sections are a ½ inch also, because they want to show the same scale of detail. Now, a lot of you put a whole lot of different ones. So I think maybe you were confusing details with section. So think about if that's what you did. If you got it wrong, like John did here. I think, John, were you thinking about the detail page?
Yes, I was.
Yeah, it's easy to get confused. And detail would be, I mean, you got everybody put ½ inch to 1 inch to 3 inch. All those would be true of a detail page, but this was a section. But you can see why a section would be a ½ inch, because it's the same kind of detail, either an elevation or a floor plan. I mean, it looks like an elevation in that it's vertical, but elevations are also ½ inch. Okay, number 10, windows and doors in structures that don't have masonry walls are located to their center lines. And that's just a standard that everybody should know because that's what they do. Number 11, what this, the verb kind of gives it away. What plan do we use to site a house on its lot? A site or plot plan? Yes. And a scale is, we talked about this, and it's not a nitpicky thing. It's just because you'll use both these words and you don't want to get them mixed up. So a lot of people will think of it as B. Scale is a proportion. The house on the plan is scale. The drawing on the plan is scaled down from the house. So that's, everybody knows that. And a scale is not the usual name for a ruler. It's just that architects or whoever engineers that triangular thing, this thing, just has the name scale. So if you go to an architect's office and he's showing you something and you say, pass me that ruler, he'll probably take your wrist out and take the ruler and slap it like the nuns do. Because they're a very arrogant bunch of architects. They have their little niche and it's real neat and trim, and they've learned this real finite amount of stuff. And so they don't like people messing with it. So don't call a scale a ruler in front of an architect. Okay. Yeah, so if anybody has a question, make sure you chime in. I've got all the time in the world here. Two types of information on a floor plan was supposed to remind you, I put types, and that was supposed to remind you of the three types, dimension, object, and annotation. But if it didn't, and that's just one way of looking at it, it's probably not a good question. I'll probably never use that again. But I was pretty broad. If whatever you put, any kind of information you put from a floor plan, I gave you credit. If you said it shows doors and windows or doors and walls, you got credit. So I was looking for that scheme we were talking about, but sometimes I have that in mind. But if you're giving an answer that answers that question and it's not what I'm looking for, I give you credit for it because your mind's not on the same page as mine, which is really fortunate for you. Let's make that clear. Okay. Elevations are like a photograph of the outside of a building. That's the best way to describe it. 15, sections, on the other hand, not being on the outside, cut through a building and show things inside walls and rooms. You got to know how important that is. There's just the way people build houses, they just have details on the inside that you would never know about unless you had a section. I've never seen a set of plans without a section. Let's put it that way. Maybe there are. John, have you ever seen any? Do you recall?
For ADUs, yeah, I've seen a couple, but not generally.
Yeah. I mean, it could be, what you're doing could be so simple that you wouldn't need it. But if it's a normal residence, it usually gets up there. What kinds of things can be seen in elevation views? You could have just gone to one of our elevation views. We have a bunch of them in the Canvas files, and seen that they show all these kind of things, doors and window locations. They show the locations. They don't dimension them. That's not done on a floor plan, but they do show where they are. They show the roof slope. That's actually where the preeminent drawing for showing a roof slope. I've seen it on section drawings because the roof's the same angle. Sometimes they'll do it on a section, but they always do it on a elevation. And then finishes, whether it's brick or stone or wooden siding, all that stuff's shown on the, it'd be hard to show that on a floor plan, wouldn't it? The wall surface. Although they do sometimes, they'll show even a detail, they'll have an arrow and it says, final finish is such and such. Okay, 17. We talked about this along the way, and I probably should have made a bigger deal out of it when we were prepping, but when we get to the roof plan, it's especially important. But when you see the word framing, that makes the plan a real specific kind of plan. when we get down to the roof frame, some people confuse roof framing plan from roof plan. And we'll talk about that in a second. But a ceiling framing plan, some of you put rafters and things, but it really doesn't show any of the roof. I mean, it might, if there's a really weird intersection of rafters and joists that they want you to see, but often that'll be in a detail also. But usually it's just joists. I mean, that's pretty much what a ceiling is. And so it tells you which way they're going, the extent of their spread, and the size and size of them. Number 18, floor joists. Again, I'm pointing out floor joists because floor framing plans have actually more on them than ceiling framing plans, because in a floor framing plan, you're trying to coordinate with the foundation underneath. So if there may be beams, girders in the foundation that are supporting the joist. So you kind of have to show that along with the joist. So the floor is connected to the foundation, whereas even though the ceiling's connected to walls, it's not, there aren't as many surprises that can happen. So I singled out just the joist, even though there's a few other things on these plans. And most of you got that right: size, direction, spacing of joist. And like John says here, they can also show piers and girders, and, and those vary. I mean, the set, our school set, the temp set we have, that floor plan has actually a lot of foundation stuff on it. And I was noticing that's not always the case. Sometimes they'll have it more in the foundation plan, and you just have to sort of, it's nice in a floor plan or a framing plan to see what's underneath, because, they go together. When you're building it, you sort of want to see it together. Question 19, plan views are always from above. That's true. Now, how is the, number 20, how is the direction of the downward slope shown on a roof plan? It's shown with arrows, but you should say the arrows are pointing down, because if they were pointing up, that would be showing it with arrows, but they wouldn't be going the right direction. So the arrows are always pointing in the downward direction on that plan. Yeah. Why do we need a roof plan? Some teachers take points off for what I call loaded answers, overloaded answers. So some students are insecure in what they know, so they put down way too much knowledge, hoping that, hoping out of that shotgun blast, one of those pellets will be the right one. But that's not a good way to learn, and it kind of shows you're not really knowing it that well. So, but I don't do that. Sometimes I'll tell you in the comments, you don't need these part of the answer, but you should recognize that as a reality, though. And you can find out, although teachers don't usually tell you ahead of time, if they're going to do. Like sometimes I'll say, name me 3 things, blah, 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 and someone will put down 10 things. And some teachers would make it wrong, because if you have to put down 3, you have to get the 3 right. If you put down 7, you got odds that 3 of those 7 may be right, but they're just odds. It doesn't show that you know anything. It actually shows that you can fake a test pretty well, but we don't reward that here. Las Vegas, they reward that, but not here. Okay, so the answer, it's a simple answer. And if you went to look at a roof plan, and I think we may only have one, Armando's building, there's not much on it. It just shows the planes. It has lines dividing the planes of the roof. And if you can't tell what it is, they'll have down slope lines to give you a little hint which direction the roof's going, the planes are going. But that's all it is, because sometimes the planes are so complicated, they want to show you, how they're fitting together. That's why you don't have them too much, because you don't really, most houses aren't so complex that you need them. So many plans don't have a roof plan, Foundation plans, all of the above, you need them because foundations may not exactly follow on floor plans. So if you did the foundation from a floor plan, all you had was a floor plan, and you took those dimensions, those may or may not be right. Because a floor may cantilever over a foundation, right? And therefore the floor plan would be larger than the foundation plan, things like that. So, and then B, to see the details of the footings, and there's a lot. I mean, that one in class, God, there's a lot of stuff in that foundation plan. And then to locate the foundation detail. So all of the above was the answer to that. 23, most common, I think everybody got that one right. Slabs and raised foundation. 24, yeah, so those, if you went to a floor plan and you looked at the section reference symbols, there'd be a circle with a line halfway. The upper half of that circle is the number of the drawing, and the bottom half is the page number. So if you went to that page, there might be a whole page of drawings and you could find it by the first number. But then there's also that additional arrow. If you turn it the other way, it looked like a roof on a house, a little arrow. And that shows the direction that you're looking. So you just put yourself in the place of that little symbol and look the way it's pointing, and that's what you're going to see in the actual section. Okay, many of you got that right. You know, some of these aren't the best questions. I'll be the first to admit it. Okay, so but we get to talk about it, so it doesn't really matter, right? Why do ceiling joists often run in different directions? So I was thinking about this, and there's probably more answers than I gave. Some of you put structural reasons, and actually that is one that I didn't put down. But it happens to coincide with the money one, because if you have to span something too big, you're going to have to oversize the joist, and then it's going to cost you more money. So the money actually covers that one. But you could say that they have to run the way that's most structural. And so the third one was to keep the attic or floor above flat. So here's the thing. Say you have a hallway down the middle of your house. Hallways are what, 3 or 4 feet across? So you're not, say it's a 20-foot hallway. You're not going to put 20-foot 2x8s or 2x10s the lengthways of that hallway. That would be absurd. You're going to put little 3 or 4 foot joists across, but you're not going to put 3 feet 2x12s to match the 2x12s that are in the next room going the other way, right? I mean, that would cost a lot more. I've seen people do that to make it all the same size. They make them all out of the widest piece of wood they need. They make everything else that way, no matter what size it is. That's done too. But if you're going to use smaller wood, like 2x4s would span a 3 or 4 foot opening, fine. If you put them on top of the wall, they're going to be 6 inches lower than the possibly 2x12s or 2x10s in the next room, those joists. So you're going to have to make it even somehow.
Sorry, can you say that one more time? They're going to be taller than what? Interpreter missed that.
Okay. If all the joists sit on the top plate of a wall, so the bottoms of the joists are at the same place. If you have little 2x4 joists going across the hallway, they're only 3.5 inches up from the wall, top of the wall. But if the room next to the hallway is a bigger room, say it's a square room and it requires 2x10s going across, they're going to also sit on the wall on the top plate, but they're going to stick up a lot higher than the 2x4s. Want me to draw it?
Absolutely. That would be great.
Without a doubt.
Yeah, I got this expensive whiteboard here through County of Santa Barbara. Charity. So let's see, I gotta, what do I have to do? I'll stop sharing, I guess. And then I'll go back to speaker view and, oh, wrong one. Now I guess I have to pit. Okay. And then I have to, where am I? I'll have to pin myself. Okay, there we go. I'm glad you asked because I got to make use of this thing. Except now I don't know what I did with the, here it is. Can you see this? Yeah, you can see it. Great. Ah, I'm doing so good. Okay. So let's say, that's the top plate of a wall. That's the bottom plate. It's got studs that are straighter than that. So say the hallway goes to here. And it's got little 2x4s going that way. So you see the, and then this room is a big room, and it has joists going this way because it's got to span more.
Katie, do you mind?
So see how much higher these are for this room? And these little 2x4s in the hall. So if you have a floor up here, if you have a second floor or you want a smooth attic floor, it's not gonna, those little ones aren't gonna reach it. So you're gonna have to do something to put those up, maybe do another, no, I don't know. Maybe have the hallway higher, you know, so the top of it is the same place. Like you could put them up here and maybe do another plate. Have the hallway walls go higher. Lindsay.
Can I add a practical anecdote, Patrick?
Yes.
So I went for more storage. I wanted to plywood my whole attic.
Yeah.
At the same time, I was remodeling both bathrooms in my house.
Okay.
And both bathrooms had 2x4 ceilings, so they only spanned 8 feet.
Right.
And I wanted my plywood to continue flat. So
your other rooms were higher than that.
Yeah, they were 2x6 because they spanned 10 or 12 feet.
Yeah.
So in order to plywood it, I sistered on joists to get it to the right height.
Yes. So that's one solution. Exactly. I've seen people take the hallway framing, the walls that hit the hallway, and raise them to the height so that those little joists will be the same as the big joists. And then the rooms next to the hallway, if the joists are going, you know, they hang the joists on that hallway wall down a little bit. So there's a whole bunch of solutions, but usually if it's a second floor, you have to have it even, obviously. And if it's an attic, sometimes they let it be different heights, like John was just saying. And if you want to make it flat, you've got to put little shims of wood in there and then put the plywood over it. Nowadays, I think they make them flat. It's kind of an older style house where they didn't care. People maybe didn't own as much junk as we do, and they didn't need the storage. my attic's full, but so Lindsay, if that's still not clear, let me know.
To be honest,
Yeah.
Lindsay, don't get it, but Katie does, and she took over.
Okay. It's not, you guys aren't builders, so it's not going to be obvious. Okay, let me go back. And you know, if Hugo or anybody is still confused, we'll just do it as a separate thing in the next class. We don't have to do it tonight. So let me work my way back here.
Thank you for doing that, by the way.
Oh, sure, no problem. Any time for anybody, I'll do that. That's what I'm here for.
Teamwork.
Katie, was that you? Okay. So, oh, Lindsay, I should have showed the floor plan for this. So if you're looking down on it, so if you're looking down at it, this is the hallway and it's got little, since it's only 3 feet across, they don't need to be very wide. You can just have little 2x4s. The next room may be a bigger room and it's a square, so it doesn't matter which way they go. And they have to be bigger because it's 20 feet. So where these two meet right here is this. Is that cleared up a little bit?
Now me, Lindsay understands, and Hugo also said like, yes, I've got it. So
Okay.
thank you. Yes, now
Yeah.
I do get it.
I
Thank you
meant to
very
do that top view before and I got distracted. Yeah, okay, great. Okay, so. Okay. 26. Oh yeah, so for Lindsay and Katie and anybody, so if they're smaller, like little joists that go across the hallway, those are going to be cheaper because they're just little short 2x4s. But if you have to use 2x8s or 2x10s that go 20 feet, those are going to be more expensive. So you always try to span the shortest side of the room. It was a 6x10 room. You try to get the joist to go 6 feet. So they don't have to be as wide. So therefore, all the rooms, oh, I don't have my board. All the rooms around, oh, I do have my board. You can see it there, right? All the rooms around, the joist could be running different ways because they're trying to go the narrow part of the room, across the narrow part of the room. That's what this question says. In order to be able to use smaller joists to save money and sometimes to keep the attic. Okay. All right, we're going to move on. Question 26, to understand the shape of a house. I always say floor plan and elevation, but when you're trying to see the shape, you don't really care about the interior wall division. So a site plan would also have that same shape, smaller dimension, but it would tell you the shape of the house and show you the, so some of you put site plan and elevation plan, which was fine. Sometimes you get a set of plans and you go, well, they drop it in your lap and you go, well, what does this house look like? Just tell me basically what kind of house it is. And, if it was a simple house, they could say, oh, it's a big regular rectangle with a gable roof. That's it. Well, you wouldn't need a drawing to tell you that. But if it's got any kind of complication to it, rooms jutting out here, and then you need the plans to kind of make sense of it. Okay, 27. Most of you got this right. The ones who missed this, oh, well, I was going to say you can take the math class, which is coming up. And we do it. This is just right for those people because a lot of us, our math is really rusty. So I tried to go through it quickly, over the classes before this, but it may have been too quick or not enough practice for you. So I'm going to go over it right now real quick, but well, I won't even do that. I'll walk you through it verbally and hope you can get it. Like I said, it's only a few of you that missed it. So, but, oh, hey, is Donna here? Donna,
Hey,
Dave?
I'm here.
Oh,
Yeah.
no.
It's a triple A chair. I found it in someone's trash. It's like they're like punchy.
I meant to ask at the beginning, Donna.
I found
What?
it in someone's trash because it's like.
So I'm giving the test answers and you haven't taken the test yet.
Well, I can exit.
Yeah,
I don't wanna,
you probably know all this stuff, but can you, we're only
you want
half,
me to come?
yeah,
I
come
can
back.
exit and come back.
Yeah, come back at, let's see, what time is it? 6:41. Come back at 7:15, would you?
Will do. Thank you.
Okay, okay, great, thanks. Remember, John, I was talking about that before, what I was gonna do, and then I didn't follow through on it. Okay. This happens all the time. People get absent day of a test and the next day I go through it. And so it's not much of a test if I give them all the answers ahead of time. Okay, so the subtraction, when you look at this, some people even get confused by subtract something from something. You know, in elementary school, we're given a column with 8 foot 4 inches on top and 6 foot 11 underneath. And we're so used to having it set up that way that sometimes when you put it verbally, it confuses people which one's on top and which one's on the bottom. Now, the way to get around that confusion is the biggest unit on the left. If it's decimal, it'll be the ones, tens, or hundreds, whichever is the biggest. In feet and inches, it'll be the feet. The feet, one number has to have bigger feet than another. So that one will always be on top. That's the way you can set up the column. So 8 foot 4 will be on top. And then 6 foot 11 will be underneath. And you can subtract 6 from 8. So yeah, it's bigger. But first you have to subtract the inches, and you can't take 11 inches from 4 inches. So that's the first problem with that. So we have to borrow, just like you did with decimals when you're a kid. You have to borrow units from the next division. So instead of tenths, this will be twelfths, because this is a 12 system here. So you'll have to take one of the 8 feet, turn it into whatever its subunits are, which at feet they are inches. So that would be, if I put 7 feet, I have to take one of the feet and divide it into inches, 12 inches, and add it to the 4. So that would be 7 foot 16 inches. And that you can put over the 611 and do regular subtraction and get the right answer. So it's a matter of borrowing when the top, it'll only be the inches, because you can't have both feet and inches bigger on the one at the bottom, because you couldn't subtract them. So, but when it is inches, you're going to have to borrow. And when you borrow, make sure you convert that one unit to 12 subunits instead of 10, like you do when you're doing decimal system. Okay, that's all I'm going to say about that. Yeah, the other was an addition. We'll get to it in a second, but it's the same principle. Okay, why are detailed drawings drawn at a larger scale? I mean, it's pretty obvious, but I wanted you to say it. You know, I mean, it's because a larger scale makes things bigger, and sometimes you need a bigger drawing to see the fine details. 29, if floor plan is missing a key dimension, how can you find out what it is? Most of you got this. You can add and subtract if there's neighboring dimensions. Sometimes you can do that and find the missing area you're looking for, or you can just take your scale. Either of those was an okay answer. Some of you put both. You can just take a scale and measure it yourself. The dimensions, it's better if you can take dimensions, if adequate dimensions are put on a plan by the designer, because then when you're building, you can just take those numbers, and if those numbers don't turn out right, then the architect and the client can't sue you for building it wrong, because you went right along with the plans. When you measure yourself, if you mismeasure and bill it wrong, then you're going to be responsible. So, you know, it's better if it's on the plan, but unfortunately, sometimes you need things that aren't on the plan. Okay, question 30. Here's the addition one. And it's the same thing. These can be put in any order, obviously, on a column, but you're going to be adding 10 and 13 inches, which becomes, 10 and 3 inches, which becomes 13 inches. And you can't leave that by itself because 12 is the limit. And when we express inches, so you take 12 out of that, and that becomes another foot that you can add on to the 31 to make it 32. And then you've got one left over that'll just remain that inch. So I think most people have the idea of carrying, you know, and moving a unit from this column to the next one. That's the basic principle. If you got that, you got it made. Okay, 31. Now, let me say one more thing about the math. If you're not sure you'll take the measuring and calculating CT 118 that we offer, I think we're offering it next year, fall or spring. I'd be willing to come early, you know, half hour before class. I'm there anyway. Sometimes people chat with me, sometimes people have questions, but you're welcome to come early and ask me to go over a few problems with you if that's the simplest way for you to learn that a little better. Okay. Okay, 31. Why do we need annotation notes on plans? Because a picture is not always worth 1,000 words. Who said that anyway? Confucius? It's often worth 1,000 words, but not always. In building, sometimes the pictures, which would be the drawings of things on the plan and the dimensions, sometimes that's not enough information for you. So you actually need some words to explain it. So you have an arrow and a little detail that tells you what to do. Okay, 32. Yeah, this we did in class, that exercise. Sometimes all the dimensions from the property lines to the house will be in obvious order, and you can just take them from that. Oftentimes when the house is skewed on the property line and they don't give enough information, you have to what's called triangulate. It's what's the other word for that when you triage? So you have to find other places where you can sort of deduce what the information will be. And that's what we did in that exercise. How do you show deduce or deduct? You guys amaze me. I don't know how you do it. They should give priority to the vaccines to interpreters and captioners before other people as well, you know? They're a special online, what do they call it? At the front service person. And we can't lose many of those because they're so precious, right? And necessary. I say give them the vaccine right away. Okay. 33. So we went over this. You may have missed it. You may have been absent, blah, blah, blah. When you're siting, like we did on this exercise up here, and you're trying to put the house on the site. You got the plan. The plan's got it on the site, but you're now standing in the real world on the lot. And you go, and you want to at least get one wall. And then usually if you have one wall, it's perpendicular to the rest, unless you got a lot of circles. But even that is pretty easy to do with, with an arc, you have circles, if you have the radius. So it's really the one wall that starts it all off. That's the critical thing. And you need 2 points for a wall. It's a line and you need 2 points. So most of you got that. this one was hard for everybody, and that's because this is a thing we do in the framing class, and it's not, you know, not all of you are here to become framers and carpenters. You know, there's a million reasons to read blueprints. You might work in an office and need it. So this is kind of complicated. So you know, it doesn't bother me that it was troublesome. For the ones who are actually building or framing for a living, this is useful. But remember, we showed that section that had the foundation, and then it had on top of the foundation was a mud sill or sill plate, and then the floor system was on top of that. And then on top of the floor joist was sheathing, subfloor sheathing. And then on top of the subfloor sheathing was finished floor, like, you know, pine strips, strip flooring. The plan, the site plan gives the elevation above sea level of that finished flooring. Remember, we looked at it? If you go to any site plan in the middle of the house or a garage, if the garage is a different height, there'll be a number and it'll say, you know, 270 feet above sea level. So you want to find out where the form boards are above sea level. So you're going to add up all those things: subfloor, finished floor, joist, sill plate, to get to the top of the foundation. The sum of all those thicknesses, you subtract from that elevation, and that gives you the elevation of the top of the form boards. So what? Now it's 270 feet above sea level. Well, how does that help? Well, then you go to the benchmark on the plan that's at 265 feet above. So then you know that top of that form is 5 feet above that benchmark. So benchmarks on a fire hydrant or a manhole cover on the street, you get your transit out, you put it right over that manhole cover. Make sure you have friends that are keeping the cars from running you down. Then you shoot to the house site where that height is, and then you go 5 feet above that or whatever it is. So you work off the site plan, you work off the elevation of the house and the benchmark, and adding up all that intervening material. So if that doesn't make sense, I'm not going to be able to make sense of it without going through a lot of pictures and stuff, and I don't want to do that tonight. If enough people want it, I should have polls in the chat section for people to, you know, score what they want to go over more. But anyway, if you mention that the elevation was on the plan and you work down from there, something to that effect, you didn't have to go through all of it. I gave you credit. So John, let's see what John said. The ability to use a site or foundation plan to find the height of the top of the forms from a benchmark point. So he's going from the other way. The builder can then use a level to do it. So you could do that. The builder uses the level to find the finished floor of the house, but in order to find the exact place where the form's topped, you'd have to subtract from that, you know, that elevation of the floor. Okay, 35. If you want me to talk more about that at some point, see, here's the thing. There's a lot of details in blueprint reading. And this class, I've got a spread of people that are just new at building. It's the first time they've seen a blueprint. And guys like John have been building all their lives and use plenty of prints. So I can't go too deep for most of you. So if a few of you really want to know something more, if I know it too, and I can help you, let me know and we'll do it before class, or we'll figure out a way, okay? 35, the benchmark and boundaries and house elevations on the site refer to elevation above sea level. Now, yeah, no, that's right. You got to still use the sea level. Trying to figure out a way around it. Because the marks that the engineer or surveyor puts on the manhole cover and he does the site plan, he'll put it on a different elevation for the first floor height. Those are all given from sea level. That's how he does it. So you can zero it out at the benchmark, the manhole cover, but then you still got to go the same distance. You know, you've got to make sure you subtract the sea level from the house and the sea level of the benchmark. If you do that, if you're going to zero it out, which everybody does. Okay. So this one was, okay, so we're citing that house and we've got that first wall, right? We got the 2 points. That's what we talked about in the previous question up above. Then you want to get the rest of the walls. So remember I said if a house is a rectangle and you've got the first wall, you just have to do 90-degree lines from the end of that first wall. And then you've got the walls going the other way. And you can measure the length of those walls, that's on the floor plan, and then do your final wall, unless the house goes in other directions. So the only way there's 2 ways to make a perpendicular as far as I know. One is to do a 3, 4, 5 right triangle that we discussed in class. You know, when we arced the end of it there with the tape. And the other one is to take a transit or a building level. And they've got a scale. What's that called?
Vernier or something.
Yeah, hernia. Well, I got the end of it, but I can't remember the first part. Vernier or hernia. They've got a scale that's 360 degrees. And when you set the level over one of the points of the walls, you go back to the other point, the second point on that first wall, and you fix that scale at 0 at that point. And then you turn the transit or the scope to 90 degrees on that same scale. And then that's pointing at exactly 90 degrees. Now transit's better because when you do that, then you can lower the transit so you can make a mark in the sand. If you have a builder's level, you have to have someone with a stick and you'll have to transfer it down. But I was only interested in you guys knowing the 3, 4, 5 rule. That really does work. I mean, people use it as much as they use a scale, a builder's level. Okay, 37.
I'm sorry to interrupt
Yes.
you.
No
This is
problem.
Katie this time. I'm not understanding transit. You do something in the sand.
Yeah. So have you seen those things that surveyors use? They're like a little scope on a tripod. Maybe
I have.
You have. Maybe Hugo hasn't. I don't know. But it's a scope on a tripod. I mean, if he hasn't seen it, that's what it is. And so you can use that, setting it over one point and find a 90, and you have a line that you're going off of. You can find the 90-degree perpendicular line with that instrument.
Thank you.
Yeah. So the 3, 4, 5 is really handy. I mean, it seems like such a simple, funky method, but it really does work pretty well. You know, you wouldn't want to build a rocket ship with it, but you know, it's as we say, good enough for remodel or good enough for framing. Contractors have said over the years that the framing should be within a 1/4 of an inch. Some will say a 1/4, some will say, Rodney would say 1/8 of an inch because he's more detail conscious. But when you're framing a house, you're going to cover it with so many layers of things after that, that you've got a lot of room to have a little tiny bit of error, like within a 1/4 of an inch. So 345 works perfect for that. It's not a caliper that you would want to do something, like I said, like a rocket ship where every millimeter meant something. So 37, the site plan helps the contractor know where he grades the lot. This is, all of these are right. Because sometimes you'll have grading lines on the site plan if it's to be graded. Where to place the house, that's what we've been doing with our exercises. And how high the first floor of the house is. They've got that elevation always on the first floor. "38, why is a monolithic slab thickened?" I think everybody got that right. It's taking the place of a footing which spreads the weight out, and a thickened slabs, usually as thick as a footing, and so it will support all the walls. The weight of a house is on the perimeter, the outside edge, because the walls are above it. So all the weight comes down the roof, everything comes down that edge. So your concrete on that edge has got to be good. So if it's stem walls, fine, that just keeps transferring the weight. But when it hits the ground, it's got to be spread out enough so it won't push the wall into the ground. And of course, the slab does that because it's connected to the slab, the thickened edge. So it's really got nowhere to go. So it works out good. Slabs are a smart solution. Okay, 39. The way we do it here, and it's funny, in all the books, they show them separately. They show a footing with a little V notch, and then you pour the stem wall over that, and the concrete fills in that little notch and supposedly keeps the stem wall from falling off the footing. Even one of our minor earthquakes would eat that up right away. So, but they don't change the pictures. It's funny.
That's all
Now-
I've done.
What?
Pat, it's funny because those are the only type of walls that I've done. Those stem walls have all been poured with the footing first, and then the wall later with a keyway. They call it a keyway. That little groove is a keyway.
In Southern Cal, you've done that?
That's all I've done. I've never
Really?
Yeah, I've never done it another way.
Well, are your houses done through the building department?
Yeah. I mean, I work for a pretty big company here in town. I've
Really?
only been doing it 3 years. Yeah, but yeah.
Well, no, but that's really an interesting thing. I'll have to check up on it. I mean, a lot of, like all of our plans that we have, especially that temp plan, that's not even new, but that shows rebar up from the, I think it's a block wall foundation. So it's the same thing. Well, block wall, they do separately, obviously, but they have rebar coming up.
Right.
Yeah, that's interesting.
Yeah, and even on really big, like a really huge footing, and then it'll just have not as big of a, a wall, stem wall coming out of it, but it's just.
And you have no rebar between the two?
Yeah, rebar coming up out of the footing.
Oh, okay. Well, that's what the difference is. They
Yeah.
used to, some of the pictures don't show rebar, they just show the keyway. Because I think they did that originally, but they found that any kind of seismic activity would not hold a wall.
Yeah,
in there.
no, definitely, like it all has had rebar.
Yeah,
And rebar and the keyway.
yeah. Well, then I'll did anybody get that wrong? 39? Did you get it wrong?
I mean, like I know your version. I went with your, but I just.
Yeah.
that was interesting.
Well, yeah. So I would give credit if anybody put false there for whatever reason. You may not have known what you're doing, but I can't go with that. I just have to go with what's on the paper. If you put false, I'll give you the 2 points for it. It's funny because in my experience, they've all been poured as a unit.
Yeah, I don't know if that's new or what, but that's just my experience.
Yeah. Well, there's reasons for that. I mean, the reason they do it as one, the ones who do it as one, is because it saves time, right? You do one pour at once, you don't have to wait for any kind of setting time. Yeah. Okay. Thanks for that information. what is the purpose of the footing? Well, that's kind of what we've been talking about. It just spreads the weight bearing. 41. Yeah, building lines are usually at the outside edge of the floor system or concrete foundation. I think most of you got this right, but it's probably not well, it's a clear question, but it might not be an easy one to answer. But your book, you don't have the book, that's right. I've talked about it. If you missed the discussion, you might get confused. So when a plan, and all the plans show building lines, a floor plan, you see a wall in a floor plan, right? You see the two lines marking a wall. That wall is the framing. So you can measure on a floor plan, it'll have the length of a wall, but you can also measure it and you'll realize that it's the framing it's talking about. They're not talking about the wall with all the waterproofing, rigid insulation, stucco. That's another inch or two on top of that. So the building lines are the outside of your frame because they're designed for the framer and the foundation people. They're not designed for the insulator and the stucco people. They don't have to think much. The wall's already there for them. They just have to apply what they're doing to it. So they don't have to think about measurements, the thickness of the wall or anything. But the foundation guy and the framer, they could be the same. That's where they have to have it right on the building lines because that's what this plan says and that's what's legal. So if their house is different than the width of the building lines on the floor plan, then they're in trouble. So that's why I'm trying to stress building lines and them being on the edge of the floor system or the concrete system. Okay, 42, everybody got that cement masonry unit. I put that in there because nobody ever calls it that. Lindsay, would you ask Hugo, since he's probably our only mason here, if where he works, they call, and I'm not sure he would know this because he's not hearing it, but he might have seen it in writing. If they call cinder block cement masonry unit.
No, honestly, I'm not really sure about CMU. I'm not familiar with it. So.
Okay. But does he do block wall foundations?
I'm not really sure. They use a lot of different ones. I think they're just calling them cement blocks.
Yeah.
Most often, or they might be using, I can't see, Lindsay can't see Hugo that well. Or they might call them, I think it's Portland, P-O-R.
Portland cement.
Oh, hold on. Let me get his attention. That.
Yeah, he was dark.
Exactly. Portland cement. So they might call it either of those two things.
Yeah. So, cement, often they call them cement blocks, but you know where the word cinder, John, do you know where the word cinder comes from? They're kind of porous, the blocks, like they're not just some straight cement that's dense and solid. They've got kind of air pockets in them. I think that's to make them lighter, maybe. But I think that's where they get the word cinder, because like a volcanic cinder is sort of, volcanic rocks, kind of airy.
It is a brick made from small cinders mixed with sand and cement. So it is some sort of volcanic, like pumice or something like that.
Yeah. Okay. So a lot of people call them cinder blocks or cement blocks. You don't hear cement masonry CMUs very much. In fact, when I first saw it, I thought, what the hell is this? So that's why I put it there, just so if you're in that field, like Hugo is, and others of you may do foundations.
Yeah, they don't use that where I work.
Okay, well, you never know.
I've
All
heard
right.
of you before.
The contractor and the masons may not use it, but it may be on the plan though, done by a designer in Iowa, right?
No, I've referred to CMU before.
Oh, okay. Yeah, so I just did that so you guys could make sure you realize it's call different names. LVL, this happens every time I do this. I say, what is an LVL? And people just spell out the abbreviation. That's technically not the answer. If I wanted that, I would say, what does LVL stand for? If I say, what is an LVL, I want to know what it is. So, but I gave you credit no matter what. So it does stand for laminated veneer lumber. And it is a piece of engineered lumber that's made up of laminations. So LVL, laminated veneer lumber, was a fine answer. If you went a little more into that, it was engineered and maybe how, that would be great too. So what is engineered lumber? I know, what a crazy question, huh? But, you know, you may be supervising a crew of novel, you know, new carpenters or laborers, and they say, you know, they say, somebody told me to get the pile of engineered lumber. What does that mean? So you'll have to explain it to them, right? Okay, so you know what it is. And then I couldn't resist, what is lumber? So those kind of questions in life are really good because it makes you think about the obvious and go, well, what is lumber? Well, everybody knew it comes from trees. That's really all you had to put. You know, lumber's manufactured in a way also, right? It's not manufactured like engineered lumber where they do a lot of processes to it, but it's run through saws, and that's a manufacturing process. So it's just trees run through saws for, you know, dimensional lumber. But, you know, most of you got this directly from trees. That was fine. 2x4s, everybody got this. It's great. We all know they're smaller now. They're 1.5 inches by 3.5 inches. What does a hold down do? It does hold the frame to the foundation, which is the briefest answer you could give, and that's a correct answer. I was hoping for a little bit more because anchor bolts also hold down a frame to a foundation. I was wanting to contrast with anchor bolts, but you know, if you're not a builder, that's going to kind of go over your head probably. Anchor bolts are in concrete and they just hold the bottom plate of the wall, if it's a slab, to the foundation. So the problem with an anchor bolt is the only thing secured to the foundation is that bottom plate. And if a hurricane comes or an earthquake, the studs are only nailed, 2 nails into the stud from the bottom plate, and they're nailed from the underneath direction, which means they can pull off real easy. So an earthquake will just take those studs and pull it right off the plate. So it doesn't do much good. So now they said, okay, we're tired of the whole houses being shifted off their foundation. So the engineers developed a piece of hardware that connects the foundation to the studs in a certain area, usually corners, and that will hold the wall more secure than just the anchor bolts. And somebody put, I think it was Duke or somebody, that also, if you're going up multiple floors, those anchor bolts are often have wires that go up and hold the, you know, the other floors to the foundation also. So that's true. Somebody put it, I think. Or else it was one of those really bad nightmares I had. And I had a teacher at City College with his choking me going, what is it? What is it? What is it? What is it? You know, and I couldn't come up with it. You ever had those nightmares? Okay. Okay, 48. I'd love to know what the exact words our interpreters use for my deranged monologues. Okay. I guess interpreters need a sense of humor too, huh? You guys are great. Okay. Plans submitted to the building department must be drawn by an architect. No, you can draw them yourself. They should be legible so the building department can understand what you're doing and critique it. So if it's not legible, they may say, can you, make these a little more formal? So you have to get a straight edge out instead of a sketch. Simple thing could be a sketch, but hey, Donna, oh, Donna's not here. Oh, she might be back. Okay, we got to hurry then. 49. Well, everybody got this. Inspectors need to come at periodic places in the sequence of the building because you cover up things that they need to see. And so they have to come before they're covered up. It's pretty simple. And then last one, California. This is a relatively new law, 65%. That's almost 2/3 of the waste from demolishing or new construction, whatever is waste material, has to be recycled or reused, and you have to document it. And the person in the building department has to approve that documentation. I have a feeling it's pretty lax these days because we don't have a lot of places to take stuff.
So Patrick, on that, how do you document if you're replacing fixtures and stuff? Do you like donate them to Habitat for Humanity, or how do you?
Yes, you used to be able to do that, but they went out of business. So they're no longer in Santa Barbara. I don't think the whole place did, but the e-store is not here now. So if you can find a place, maybe a light store will take old stuff and try to redo it. But I think, Carol Ash and I have been talking, one of my colleagues have been talking about this a lot lately because we're not happy with it. And what most contractors do is they go to Marburg and they say, I need a couple of, bins brought out to my site. I want one for trash and I want one for metal and I want one for maybe rubble, or however they want to do it. Marburg comes out, signs off on whatever is in them, and then Marburg takes them to their plant, downtown, and whatever they can salvage, they do, and the rest just goes into the waste. So it's not necessarily everything that's they haul away is going to be, reused or recycled. But it's the only, right now, because the places that take that stuff are not taking it. Rubble, like stucco and concrete, used to be able, some of the places that do road work, like lac and granite, used to take that stuff, say, yeah, you can bring it to our yard and we'll use it. And, that still works, I think. John, some of you that are in the field right now may know if they're still doing that. It goes off and on.
They're not officially taking it, but if you take it in, they'll take it for cash.
Yeah. Yeah.
So
They'll take it. They'll
the supervisor there will take it if you pay cash.
Oh, you have to pay them.
Mhm.
Yeah. See, it used to be for free. So they've up. Yeah. So it's not a great situation right now. We're kind of in the middle of a crisis, landfill crisis. Now the landfill has a, Carol and I are going to go out there one of these days. We want to see what they have a new plant that recycles out there in the landfill. I want to see how much they do. It's easy for this stuff to get kind of, no pun intended, swept under the carpet. And so it seems like it's going, and the landfill can say, oh yeah, we recycle 80% of our waste stream. But, people lie, as you know, especially in politics. And those figures may not always be true. And it's a serious thing if we're overloading our landfills. So anyway, it's great that California keeps making the amount of material, required to be reused or recycled. I like that. Someday, we're going to have an industry that the designers use material that can be real easily reused. It'll be modularized. And, people like the independence of having any old kind of material they want. And it could be really spectacular, costly stuff. Gives them a lot of status. But it could be real wasteful. It could be stuff that can never be used again and ends up in the landfill. And I think our whole design, the whole industry is going to change. That is, if we survive nuclear holocaust and global warming. That's got to come first. We'll change to be more, efficient with our materials. People have to want to do it. If people say, yeah, I'm willing to live in, anybody know of the architect Frank Lloyd Wright? You should look up his stuff. I'll send out the spelling. And he did these, talk about cinder block wall houses, and actually the LA area was his biggest place. But he had the blocks made, so they were very decorative. They were really beautiful, but the walls were all block. And it was pretty darn beautiful what he did. It was amazing. But that guy could do that. That guy could, if he's still alive, he's dead. He's been dead 50 years. But if he was still alive, he was such a great designer. He could design modularized materials that could be used. And it's the way that they're used that makes it unique and different for each person. So it's fine for people to want uniqueness and cool designs, but we need to do it in a little more constrained way, so that we don't just waste all the stuff we're designing with. That's my 2 cents on it. So, okay, any other questions about the exam?
Where can we look at our answers, like what we got wrong?
Oh, John, you're gonna have to help me with this.
If you go to quizzes and select this quiz, you can see it, but also on your home screen, you can go to the right-hand side and you can see an announcement about Patrick giving you your letter grade. If that does it.
Okay, try that, and if you can't get to it, ask me again in the future, and we'll nail it down. Well, I mean, I think John's right, but we'll actually go to it on the screen so you can do it. Okay.
Yeah, no worries. Thank you.
Yeah, you're welcome. Yeah, I didn't realize, I'm new at this too, and I thought, like John said, there's a way to get to everything. They don't throw away information. That's the great thing about the information revolution. They don't throw anything away. It's both a good thing and a bad thing. But in these, Canvas saves everything, but the trick is how to find it. And John's a smart guy, so I always go to him. Some of you may, if some of you are really good at Canvas and the ins and outs of these systems, chime in. I'll use you. I'm tired of using John. He gets boring after a while, but so I welcome the rest of you to help me. Okay, so I'm going to go. If you have questions, you can email me questions. You can bring them up next session we have after the spring break, and I will anytime address questions you have. I don't care how old the material is. So just know that. Okay, let's get out of the share. Oh yeah, what time is it?
7:23.
Yeah, shall we go till 8? Let's go till 8. So the syllabus says construction from prints. So those of you who are learning prints, not to construct, but maybe in a designing office, an architect, or maybe as an inspector, we always get some inspectors here. This may not be so critical, but I think, well, it actually would be for inspector, because they need to know not just what the plans say, but actually how things are done, because someone may do it wrong and the inspector has to go out and say, this is not up to code. And they'll ask, well, what can I do? And you want to ask the inspector because they're going to come out and okay it eventually anyway. So you just want to say, just tell me what to do. So they actually need to know. Donna, are you there?
I think you told her to come back at 7:30.
I thought I said 7:15. Anyway, yeah. So they need to know too. In fact, the better inspectors are the ones that know more. In fact, the best inspectors have done building themselves, but there's so much need for inspectors that most of them are just trained off the street and may not have a lot of experience, which is unfortunate, but overpopulation drives everything to extremes. Okay. So the first thing you do is you get a lot of this will depend on where you are in the hierarchy of building positions. If you're a laborer or the bottom carpenter, a lot of these decisions will be done for you. But if you're a superintendent or a supervisor, even a crew leader, this stuff will be relevant. So somebody ordered the wood for your site, right? Off the plans. Sometimes people send the plans to the lumberyard and the lumberyard will do it for a small price, a reasonable price. And then since they're going to send you the wood, it's real convenient. They know what they have, they know what they can get. It precludes a lot of extra work on your part, but you got to pay for it. So, but you need to get a hold of, you need to find out what they, how they, what kind of wood they use for different things. Now, there's a service. Did one of you, is this class, one of you work for the truss plant up in Santa Maria? Did anybody in this class work there? It could have been my other class, my morning class. I've got a new class in the morning and some of those guys are billers too. Yeah, maybe in that class. But anyway, do you guys know about that plant, that manufacturing plant in Santa Maria? I know John does, but they make trusses. It's a Hayward lumber plant and they make trusses. So if you order trusses, you can do it relatively close by. But they also were into bundling up materials so that they would cut. There's a new service. I think it's still going. I never liked it much, but I never used it, but I never liked the idea. And that is you give them the plans and they not only get the raw wood stock, but they'll cut everything to the dimensions you need in the plan. So if you need so many joists at 6'5", a certain size, they will cut those and they do it at that plant. And then they give you a package. They just truck all the lumber to your house, but it's in bundles. This is for the ceiling joist. This is for the foundation material. This is for the studs. And it's all, diagrammed and packaged. So you don't have to cut much. You just have to put it together. So I never liked it because I thought it took away a lot of the creativity and, craftsmanship from a carpenter, because you become just a person that kind of plugs things in. So I don't know if that's continued or how it's caught on. Does anybody that's framing or is at a site when the wood comes notice that being done?
Sounds like something great for an owner builder or something.
Yeah. Yeah. It would be good for a person who would have trouble doing it themselves. Yeah. Yeah. That's a good use for it. So if it's not done that way, the traditional way, if it's done the traditional way, so if you need 4-foot 2x4s to go across a hallway ceiling, like we've been talking about, and then you need 6-foot 2x4s for another use, they will often take the 6 and the 4 and give you 10-foot pieces. So to save wood, right? They're not going to, the smallest piece you can get is 6 foot. So if you take a 6-foot piece for a 4-foot piece, you're going to have 2-foot waste. That's half the piece. You don't want to do that. So they're going to try to stack stuff together in normal size pieces. But when you get the wood at the site, when it's delivered in one big bundle, you got to know what they did, because otherwise you'll be cutting up pieces and you'll go, oh no, I just cut a bunch of rafters because I thought they were joist material. And then you don't have the right wood for rafters and you got to reorder. So the first translation from plans to material is important. It's done in the ordering. Either your company does it, they have a person that does the takeoffs or lumber list, or it's done at a lumber yard. But you need to be aware of that if you're one of the people on the ground that's going to use that material, so you don't misuse it. So a lot of times in the past, when I was in the field, that's one of the things I did is I would go to the stack and start separating everything. You put the foundation stuff first, the floor stuff next, the wall stuff next, the ceiling stuff, the rafters, and you get them in different piles. And you make sure you have enough of each one so you don't miscut anything. You know, a lot of wood overlaps. You may have 2x8 rafters and you may have 2x8 joists. And they may be a specific length for each one, so you don't want to screw it up. So the first thing you do in going from plans to the construction is making sure the material is organized and in the right way. Yeah, everybody got that? Some of you may already be doing that. Now, there's so I wasn't sure when I was thinking about this lesson, I wasn't sure how specific to get, how detailed, how relevant that would be for the majority of you. I know for some of you it would be, but the first process you'll do is after the foundation. You may be involved in doing the foundation, but you know, we've gone into that a little bit. But other classes at the construction program go into that more. But your floor system's the first one that we're kind of familiar with because we've been looking at framing plans of floor systems. So there's a lot of things you have to do. The first thing you have to do is make sure the foundation was done right. If you didn't do it, you're inheriting the work of a company that came in and did it. And you don't know if it's done properly or not. If it's a company you've worked with before and you trust and they're a good company, then you don't need to worry about it. But if it's a new company, but anyway, you have to check it. So you have to make sure it's square. You know, it's a perfect rectangle if that's the shape of the house. And, you know, concrete can be put in too fast and too much bulk, and it can move form plates. There's a lot of power if it's done with a hose, a concrete pump truck, a pumping hose. A lot of power in those, and they can move things. So, and you wouldn't notice it. So when you're done, you got to go. And what you do is you take your tape measure and you go from outside one end, outside wall to outside wall, end, center, and end, and make sure that dimension's all the same, right? Because they have to be parallel. Opposite walls in a building have to be parallel. So you have to check and see if your foundation's parallel. If it is, everything's fine. Then you just proceed. You can use the outside of the wall as a fairly straight indication. If it's off by a lot, like a foot or 6 inches, which it usually won't be, then they'll have to redo it. Or you'll have to kind of come to some understanding with the concrete people. If it's off a half an inch, 3/4 of an inch, the carpenters can deal with it. So they have to make sure their plates, their sill plates that go on top of the foundation, one could be straight and the other one, because the wall's not straight, has to be tweaked a little bit. So it will either hang over the wall a little bit, and then the other end will come into the wall a little bit. Now that's okay up to 1/4, half an inch, because you're going to put more stuff on the wall. Sheathing. You could cut a hole for the sheathing if it's in the way. Maybe rigid insulation, inch or two of rigid insulation, stucco, whatever. Those things will all hide those errors. So the first thing you do is make sure the building's square, and you put your plate on to compensate for it if it isn't square. And then when your plate's on, then you're going to measure across the plate, and that's going to tell you the size of your joists and your headers, right? Okay, so now we can go to, I want to share this with you. Oh, hold on. Boy, what I do for you guys, I tell you. I sit at home and make these drawings all day long just for these classes. Pretty crazy, huh? Okay, so can you all see this? Let me make it a little bigger.
Yeah, more or less.
Yes.
Okay. So, oh, same old thing. And I'll just make it bigger this way. There we go. So this first thing, this is the floor system that we're putting on, right? So if the foundation's been done by someone else or you've done it, that's done. And now the plates are on the foundation, and we're going to now put floor joists, and then they have headers or end joist, rim joists. They call them different things. I call everything a header that heads off a bunch of, it's like in mechanics that heads off a bunch of, like in a manifold. So that's a kind of a general term, a header, and then members go to it. But you can call it a rim joist or yeah. So there's a couple ways you can do that. This distance here, the distance of the joist plus the rims is fixed, right? That's going to be on the plans. But the order that you put them down can differ. So this whole rectangle is the size the plan tells you it has to be. And the plan knows you're putting 2x8, rim joists out here and out here. And then this end joist will be 2x8 and all these intermediate joists will be 2x8. So we know all that. So you can sandwich all the joists between the rim joists, including the outside ones. But a really great method is to put the outside one long. So it's longer than a normal joist. It's inch and a half. It's 3 inches longer than these. And then nail this way into the rim joist. And that'll keep these from pulling apart. If these are all nailed, any kind of force going this way will separate the floor a little bit. So, different people have different ways of framing floors. But this is one idea here to think about, having that outside one longer than these, so you can nail it this way. And so when the pressure comes to pull these apart at the ends, they won't give. Does everybody kind of see that?
Yeah.
Yep.
It's not critical for the people who aren't carpenters, and the people who are carpenters probably already got this 10 minutes ago. So let's put it that way. Now there's another thing with building, and that is which walls to build first. So when you're on the first story, the ground floor, if you're on a slab, you're pretty much on the ground. And you could build the walls on the ground and lift them up into place if you needed a lot of room to do it. So you could build, say, this end wall first, and then you could build this side wall. And the second one would be maybe this side wall, and then this one, because you can build them off the platform, off the floor, and then just carry them over. Second story, it's a different picture, right? Because you're on top of the other story and it's dangerous, and you got to build. You're going to build those walls on the deck, on the joist, top joist, the ceiling joist of this first floor is going to be your floor. So it's going to have plywood on it. So it'll be a platform you can stand on, but you don't have any place to the side to build those walls. You're going to build them on that floor. Then it's more important that you do the outside walls first, because then these short walls can be done still on the platform and put in place. Otherwise, you're going to have to hold walls over airspace to do it. That's dangerous. It's too hard to do. You could drop them. So second story, you want to do the long walls first. So you say you do this one, and you can build it on the platform and just stand it up. Same thing with this second wall, build it on the platform. It takes the whole length of the platform, and then stand it up. Then when those are up and braced, then you can do the end walls, and they can build in the platform between these two and stood up between them and nailed in. So those are just tips. They don't have anything to do with anything.
Patrick, just so I'm clear though,
Yes.
the first drawing is a elevation, right? And the second.
No, this is a plan too, a floor plan. And these are joists.
Oh, okay.
Yeah, I made them kind of thick so you could see it, but
These are all plans.
they're all floor plans, yeah. Okay. This people do different ways. This was just the way I was telling you that you can do something. There's all kinds of tips, you know, in building. and
Yeah,
and
I'm picking up a few little things for sure. I mean, like the I just if you don't.
right. And somebody like you or John who've had more experience, some of you others, that means more. You say, oh, that's a good idea, or not. You could say, well, what about this, Patrick? And I'd say, well, okay, you got a point.
I like the framing stuff is informative because I don't do a lot of that. So
Yeah.
it is.
Okay. Okay. Um, so so say you've got the floor done. No, we don't need that. What else do I have here? Chapter 10. Okay, can you see this floor framing page?
Yeah.
Okay. So this is the textbook that we use at school. We don't use it for this class, but for many of the other classes. And I got a publisher to give me to test an online version, which is handy because I just want to show you guys a few things in this. And then we'll go home. So this is, how can I get this bigger? That's hard to see, isn't it?
I don't think there's an especially easy way to do it, unfortunately.
Oh, that may be it.
Nice.
Is that what that plus sign means? Is that better?
Yes.
Okay. So this is just to show you how floor systems go on the top of footings. And we don't do a lot of brick here, so that one's not too common, but these are both, and there's more of these. Actually, I don't like either of these. I do it different, but these are similar. But you've got your stem wall, you know, the upside down T, and your anchor bolt holding that's what I was telling you, just the anchor bolts, just hold that bottom sill plate, it's called, or mud sill. Then you build a floor system on this. So if an earthquake comes, you know, it could just take everything above that bolt, leave that sill standing and take that whole floor and the house above it to the side. So now with the, what am I calling, what are we looking at, John? The,
HDUs,
yeah, the name,
hold downs.
hold downs, thank you. The hold down bolts go from the concrete and they go all the way through the floor system, the space, and they connect to the wall here, the studs. They go up actually a foot and they're screwed to the studs so that the framing is connected to the concrete. So it makes it a little stronger. Earthquakes then they have to pull against the concrete, which is what we want. And this shows the floor joist and the rim joist here, header they call it here. So this was just, I just wanted to refresh your memory for those of you who don't build all the time. A few more here, 246. Okay, and what might this be? Oh yeah, so this just shows, you know, when I was saying you had to get the mud sill, make sure it was, okay, the discussion I just had about making sure that these walls are parallel, that say this concrete wall here is parallel to the one on the other end. The concrete people, it may be off a little bit. So you've got to take this plate here. What things we just looked at, the plate came all the way to the outside of the concrete. There's different ways to do it. This one may be so that they can put the sheathing and maybe the insulation so it rests against the concrete. There's different ways. But you can angle these sill plates, you can tweak them a little bit if you need to do that to make the whole frame square. If the foundation wall itself is slightly out of square, then you can tweak these plates. Thank God. Okay. And this was just showing you, sometimes you might build a joist. Sometimes this is just a building difference. It may not mean too much to you non-builders. Sometimes when the joist system that the drawings I did, and typically the end of the joist sit on that sill plate. And there's a header outside of it, but all of that sits on the sill plate, so you don't need hangers. If for some reason the structure of your foundation, your house is that the joist can't sit on a wall, then they have to be hung. They have to be hung on that header because there's no wall underneath here to rest it on. So you have to have a piece of hardware and you have to hang it on, whether it's an I-joist or any kind of wood that will hang it. So I just wanted to let you remember that. And then one more, I believe here. Oh yeah, possibly two. You know, I always lie about this stuff. So sheathing, so you got a pile of plywood in that delivery from the lumberyard, and you got your floor system already made on top of your foundation. I don't see a plate under there. And then you got to put your sheathing on for the actual floor. Sheathing means plywood subfloor. Let's see if we can spell it. S-H-E-A-T-H, sheath, like a sheath, sheathing. It's a funny word. It's an old English word, probably. And those are 4x8 sheets, and they go on long ways across the joist, not long ways this way. That gives you more, it connects more joists together. So in an earthquake, it's stronger than if you did it the other way. So you connect them 8 foot by 8 foot together, and then you stagger them. You start with a 4 foot and then go 8 foot so that they're staggered. This makes the simplest, strongest floor that we know about. And in blueprints, it will specify the wood. And of course, it's been delivered already, so they got that right. The lumberyard got it right. But also the blueprints will tell you what kind of spacing for these nails. And the code has a minimum spacing, the building code. And so it will be repeated on the plans. However, it may be more rigid than the plan. It can't be looser. It can't be less close than the building code, but it can be closer. So for instance, if you had joists every 12 inches instead of 16 or 24, because say you were putting a bathtub on here or a jacuzzi or something that would have a lot of water and weigh a lot, then you might have a slightly different nail pattern on that. And the structural engineer would spell out those nails. So the nailing pattern's done for you, but you got to make sure it corresponds to whatever's on the plans. Everybody understand that? And last picture, you know, when you put the sheathing or OSB, plywood or OSB on the joist, you have to glue it. And so they have special adhesive and guns that you do. And then you have to nail it in that pattern we just saw. And we used to bend over on our knees for hours and nail. And somebody came along and discovered this nail gun that you can stand up and use. God, what a genius. And then you don't have to bend over, so it saves your back. I mean, when you're hours bending over on a deck, you're just crippled for the rest of the day. This is a great invention. And I think Simpson Strong-Tie bought out the original company that developed this, and now they own that too. Sometimes the wood is, and this John or Dawn, if she's here, sometimes it's tongue and groove, which means the pieces fit together. I'm not sure if that's required now.
It has to be TNG or the joints need blocks underneath. So
okay, so TNG it is. It's not much more money, if any, and who wants to block under that? So this joint, it used to be you could just use wood. Now they want it blocked where that joint is, so you can put a few nails in there. Or TNG so that the grooves catch the next piece and earthquake or wind, if it happens to be in a porch, won't lift that. And to get them into the TNG, you use a 2x4 and sledgehammer. Sometimes they have to be nursed along a little bit. Okay. So that's all. Hold on. That's all we're going to do for that unit of applying building. Now, if there's later on, I mean, we're only halfway through. Can you believe it? You poor suckers, you're hating it by now. But if along the way, there's more stuff you want to know about going from blueprints to building, just ask me and we'll do it. We'll do a quick lesson. If it's something that's going to be boring to the people that aren't into building enough in their career that it makes sense, I won't do it for too long because I don't want to lose half the class. But that's part of the class is not only reading blueprints, but translating blueprints into constructing things. Yeah.
I appreciate it. I find it interesting.
Okay.
Patrick, how soon do we have to sign up for the possible other classes? I think you were talking about some classes, I think in the summer or something.
Yeah, not soon.
Okay. All right.
It's 8 weeks, toward the end of this class.
I just want to make sure I don't miss it. Okay.
Yeah. No, I mean, I think I've got the first summer class, which is roof framing. And I'm going to do the labs. It's 3 nights a week. I'm going to do one of those at school. And I might get the clearance because Biden's getting this vaccination going so fast. Every week it's faster than they predicted. That we may all be vaccinated enough to have the whole school in person by summer. Hopefully, I'd love that. And then we could just do the class there. It'd be a lot. And then for the people that are far away, those of you in Sacramento and that, we're going to record, we'll record the outside sessions. We're getting set up now to do that. And
Oh, that's cool.
so we would have a record, pardon me, we'd have a video of it. So yeah, no, you have some time yet. It's mostly the people that are already taking classes that constitute our classes. And then there's a few new people from the outside. So they never fill up like super fast. So that's how it is. Marcos, does that answer your question?
Yeah, no, thank you. I appreciate it.
Yeah. Okay. If there are any more questions, what's after we come back? Hold on. So when we come back, we'll talk about using the plans for estimating, which is kind of in between. I probably should have had that unit before this one tonight, but no matter. So that'll be what we'll do when we come back. So you don't come back next week, right? It's spring break. Whatever you do, don't fly to Florida to go to the beaches.
Oh man, that's what I was gonna do.
I know. Somebody told me people were flying from here down to Baja, San Lucas. But if you go, keep your mask on and your social distancing because we're not done yet. At the rate, what is wrong with my voice? At the rate we're vaccinating, they predict after everyone gets vaccinated, after a certain percentage, we reach herd immunity. And when that comes, then we'll just be able to let our guard down and go back to normal. And that's going to come faster than we thought because they're vaccinating so fast. Although there are other vaccination resistors, which some of you may hear be too, but unless we get enough of those, it's not going to do any good because they'll keep passing the new strains and eventually it'll get to a point where the vaccines won't be effective against the new strains. So it's really critical. Some people do it out of religious reasons, and that's fine because that's a small minority, and usually this kind of program can deal with that. But when people are doing it out of political, just to snub the last, the new president or whatever, that's not good because it's going to hurt people trying to recover. So stay safe for a little bit longer, everybody. I know they're really expecting the worst for this spring break week because college kids are often bullheaded, but not you guys, okay? I'm talking about other college kids. And they insist on having their fun, but most of us are working normal people. So we'll just have a good vacation, but be safe. Yeah.
I'm working. I don't know if I'm normal.
Well, yeah, I know I'm not normal, but okay. So thanks for everything. Oh, we're 4 minutes early. I won't keep you. John, do you want to chat or we chatted before? That good?
Yeah, no, I have to go load up for tomorrow. So
You gotta go take care of your jobs. I know it's an all-night thing with the jobs you got now. So
yeah.
All right, everybody. So I will see you in 2 weeks from tonight, right?
Yeah.
I think so.
Okay.
Yep.
All right.
All right.
Enjoy your time off.
Yeah. If
Wait,
you have it, yeah.
Are you getting your back to work classes off, or is that continuing?
Well, at first they said no, and I went, wow. I mean, that's not a big deal to me because it's pandemic. I'm isolated anyway. But then they finally said, oh no, we're not going to do it over that.
Well, that's
They're
nice.
it's a special thing. They're getting paid for it, and they're getting a lot of other stuff. So that's going to go on for them. But I thought they were going to try to get us into it, but they're not. So I do get time off. And I'll put all the time into preparing for the next class for you guys. You know that, don't you?
All right, Patrick. You have a good night.
All right. See you guys.
See ya.
All right, Patrick.
Okay. So somebody send me
Thanks for everything, Patrick.
okay.
You're wonderful to work with. We really appreciate it.
Okay. Thanks, Lindsay.
Thanks.
Thank
See
you
ya.
guys. Yeah. I appreciate
night.
you guys too.
See ya.
Oh yeah, we did the survey too.
Yeah. So this is probably who's this closed caption broadcasting. Is this Debbie? Is this note from Debbie?
I just see 3 of us left here. I was gonna log off right now, but I thought you were gonna say something.
No, I've got something on my screen that's closed caption.
Oh, it just says there's 3. You, me, and
Oh, is that all that says?
and Jesus. There's only 3. Oh, no, it's just me and you.
No, but it says something about Michael, and Michael was trying to get onto the.
Oh,
Maybe that was an earlier conversation.
probably because everybody else is logged off.
Yeah, Michael's gone, so we'll just forget about it. Okay.
All right, good night, Patrick.
All right, see ya.
All right, bye.